Hello, in this video we're going to look at solving multi-step equations using inverse operations. So in order to demonstrate the process for solving an equation that has multiple steps, I'm going to use these little cards, and the three that you see that I'm holding here are inverse operations. They are things that can be done to a variable or to a value to change its value. And on each side of the card, you'll see that I've got an operation, like a power, for example, having something raised to a power of something. And the inverse of that would be square root. I've also got a multiplication. The inverse operation for a multiplication is a division. And I've got addition, and the inverse of addition is subtraction. In addition, I have two more cards here that I'm going to be using. I have the card that has the unknown on one side, so that's when I don't know the value of a variable. I've been given just a variable to hold the place of something that I don't know. On the other side of that one is given, so that's if I was given a value and I was being asked to substitute. And then I've got the grouping symbol or brackets card. So let's look at how I use these. So the first equation that I'm going to solve is 2x plus 3, and the x plus 3 is in brackets, equals 16. So the first step in solving any equation is to look for the unknown. What is the variable or the value that you're trying to locate or trying to identify? In this case, it's this x right here. Okay, and then you have to consider what are the different operations or different things that have been done to change the value of that variable or the total, to make the total 16. So starting with the x here, it has had 3 added to it. Okay, think of that like a layer of an onion. Then that was placed in brackets. And the black brackets indicate that this multiplier of 2 does not just apply to the x, it's 2 times everything in those brackets. Okay, so it's a multiplication that is a coefficient in front of a group. Okay, so that's my stacked representation of what's on the left-hand side of my equation. The right-hand side is 16. So in order to solve, in order to uncover that variable, which is the bottom card here, I'm going to have to undo each of those layers one at a time. So the first thing I'm going to undo, or do the inverse of, is the multiplication. So multiplication by 2, inverse of that is going to be a division. So I can divide both sides by 2. And that's going to leave me with the grouping symbol still there. 16 divided by 2 is 8. And it's a good idea when you're doing this to indicate if something is being canceled out or divided away. And that's how you'll see it if you're looking in a textbook or oftentimes on worksheets with a solved example. You'll see this division like a fraction bar and then canceling out. Okay, so now I've got still my variable, there it is, added to 3, and then in grouping symbols. Well, now at this point, the grouping symbols aren't actually doing anything. Okay, they were there in order to make sure that the multiplier of 2 applied to everything, but I've dealt with that 2 now, it's gone. So the grouping symbols can go away. So it's the same as just saying x plus 3 is 8. Now I'm going to deal with that addition. I've just about said what to do. So the inverse is a subtraction. So subtract 3 from both sides. plus 3 and the minus 3 cancel each other out or nullify. And I'm left with x is equal to 5. All right, we're going to do another one. So the question this time is 3x minus 5 equals 18. Okay, so drill down, find the variable. And there's only one in this equation, so this is very similar to the one we just did. So I've got the unknown. It has had 5 subtracted from it. It's in a set of grouping symbols then, and there's a multiplier or a coefficient. Okay, so all this stack of cards represents the left-hand side of this equation. And now all of that's equal to 18. So I'm going to work it backwards and remove each layer of that stack. So first get rid of the multiplier or the coefficient 3 by dividing. So now I've got x minus 5 is 15. No, what am I saying? 18 divided by 3 is 6. I did a subtraction there, that was silly. Okay, so now this set of grouping symbols, the brackets, are not doing anything. They're not actually changing anything about this equality. So I can just remove them. Now I have to undo the subtraction of 5. So I'm going to add 5. So now that gives me x on the left and 11 on the right. Okay, one more a little different. Okay, this one's got a couple of different things going on in it. Again, I do a little scan across and see I've only got one variable in there. So my unknown has had 2 things done to it before I get to that divisor. So it has had a multiplier times 3. It has had then 4 added to it and a set in grouping symbols. And then it's been divided by 2. So this fraction bar is a way of indicating that I have to do everything in the numerator first before I divide by that 2, and then the result would be 14. So there's my stack. So to isolate for the unknown, I have to undo them in order, reverse order. So to start with, I'm going to deal with this division by 2 by multiplying. I'm going to go times 2 times 2. That's going to eliminate that denominator, so I no longer have a fraction. 14 times 2 is 28. And then, as I mentioned in the previous question, at this point, a set of brackets around this expression is not changing the equality. It's not actually doing anything anymore because I don't have the divide by 2. So I can just get rid of them. Like that. Now, I've got this plus 4. I'm going to deal with that by doing a subtraction. That's going to leave me with 3x on the left and 24 on the right. The 3 is a coefficient, it's a multiplier. So to eliminate that, I'm going to divide. And the result of that division, 24 divided by 3 is 8. Okay, one more. Two x minus 1 all over 5 equals 3. Again, scan across, one variable in the problem. I'll show you in another video how to deal with if you've got more than one variable showing up. But in this one, we're just interested in one variable with multi-steps. Okay, so my variable's there. It's been multiplied by 2. It has had 1 subtracted from it. Then it has, all of that has been divided by 5. And if you wish to insert a set of brackets around this numerator to keep it together, to remind yourself that it's all together, that's not a bad idea. It doesn't hurt. Okay, so they were not in the problem initially, but that may help you to remember that division of 5 is actually happening to both of those values, the 2x and the 1. Okay, so multiply the 5 to eliminate that part of the equation. And that gets me to 2x minus 1 is 15. Right, I've dropped the brackets now, that's fine. Now I'm going to deal with this minus 1 by adding. So I have 2x is 16. This 2 is a multiplier. So to get rid of it, I will divide. And I'm left with x equals 8 again. And that's how you can use cards to model solving multi-step equations.